Hi everyone and welcome to another tutorial from SkyCiv. Today we're going to be exploring the difference between the member weak axis and strong axis and why they're so important to consider when building your structural analysis model. So this is particularly useful for students or anyone new to structural analysis software or structural engineering in general. We want to learn a little bit more about the difference between the weak and strong axes of a section. And we can use structural analysis to kind of prove our points along the way of these concepts. So firstly, what is the strong and weak axis of a section? And I'm just going to use the section builder to demonstrate and just explain this. So when people are designing structures, they obviously want to reduce the amount of material. And one of the best ways to do that is to kind of use geometries such as these I-beams, where they have quite a lot of material in the key parts of the section, like the top and the bottom, and kind of minimizing some of the materials in the middle because they're taking less load of those parts of the section. But the way, when you're using these types of sections, it's really important that you're loading them correctly because they do have a strong orientation or a strong axis, which in this case will be something equivalent to a down force in this direction, and then a weak axis, which in this case it would be in this direction. So basically what that means is that this section can take a lot more load in the major axis or the strong axis, because if you put a down force on here, you're going to create more bending moment around the Z. So if you put more wide down force, you're going to create a bending moment about the Z. And this section, since it has a really high depth and has a lot of material here, is a lot more capable of taking that bending moment in that direction, because that's what it's basically designed for. Whereas if you load it in this direction, so in the Z direction, or the weak axis, you're creating a bending moment about Y, and the section doesn't have too much material on the outside, or these outer ends, the top and bottom ends, and it's just not designed to take as much moment force on that weak axis. So there's a lot less capacity in this cross section to take a load in that direction. So just really important to consider and just to understand those concepts. So we've got a major or a strong axis here and a weak axis here, and we want to really make sure that our beam is orientated in a way that it's taking the most force in this direction. So if I go back to my model, now I just quickly built these two identical frames, or almost identical frames, and what I want to do is just review in the 3D renderer, which is always a really, really important part of running your analysis, is just reviewing the structure in the renderer to help identify problems with your model. And what we're looking for here is just the orientation of the beam. So in this case, I've got my I-beam here, and I'm not sure if you saw, there is a lateral force here, so we've got a wind load here and a down force here, same on this frame. So what that means is on the left frame, we've got the beam being loaded in the correct direction. So you can see there's a lateral force here, wind load, and that's going to be applied in the right direction for that that column. And then we've got a down force, which is going to be applied in the correct axis for this beam. And what we have on this other side is we have the opposite. We have the column is orientated by 90 degrees. So I just clicked that and I've rotated that member by 90 degrees. So you can see there, this one's 0, this one's 90 degrees. So that's how you can change it in the software. And I've got my lateral force still going in the same direction, but now that's being applied to the weak axis, because you can see it's applied to the side of that I-beam. And so what we're going to do now is just review the different results. So I've just run an analysis, and I like to usually start with the displacement. The displacement usually tells you a pretty good story of what's happening in the structure. And then you can hold the S and just kind of scale it so you can animate it and kind of get a feel for how it's deflecting under these forces. And I've got my combined loads, but let's isolate the wind load. Let's just look at the lateral force that we applied. That was this force here in this direction. And let's see how the frames behave differently. And you can already sort of see it that on this left frame, I've got 4.6 millimeters of displacement in the X direction, and the X is global X direction, so in this direction here. Whereas on this one, where we've loaded it on the weak axis, the columns are deflecting a lot more, and we're getting 41 millimeters in X or lateral deflection. So you can see by a magnitude of almost 10, the frame is displacing and deflecting a lot more on the right because we've applied it to the incorrect axis. So you can see how big of a difference these, the orientation of your beams can make to your final results, and why they're so important to consider when you're designing. Other things we can look at are some of the other bending forces. So let's look at maybe some of the member stresses and kind of how they're behaving differently. So one thing that's important to note, is that you can see this side we're getting quite a lot of stress, and on this one we're getting zero stress. That's because we're looking at the bending Y stress. And just to explain that a little bit more, when we're talking about bending Y, we're talking about the member's local axis. So I'll turn on this local axis, turn the loads off for a second, and you can see in this case the the x-axis, that they correspond to the same colors here. The x-axis is the same; they're both pointing in upwards in the x direction, but you can see there's been a rotation of the member. So my z direction on this right column is in this direction, whereas on this side it's this direction. So when I'm looking at bending stress about Y would be the members about the member's y-axis, and bending moment Z would be about the z-axis. And you can see there's no load, no force on it, because there is no load in the member's about z-axis. So long story short, we can still explain the effects that has on the member. So we can see if we look at both of these, on the correctly orientated member, we're getting a maximum stress of about 24.6 megapascals. So let's just call it 25 megapascals. The beam is under that much stress. And all material has sort of like a limit to how much stress it can take before it fails. In this case, steel's generally, you could say 350 megapascals, just to simplify it. So you can see that that's quite low. We're only using about 25 megapascals of the material's 350 total megapascal capacity. Whereas if I look at the other one, where we've loaded it in the incorrect section and the incorrect orientation, we get a much different picture. It's a different picture here. We can see we're loading the structure with 150 megapascals worth of stress on this lower end. So we're really limiting ourselves to how much this beam or this column can take in terms of force, because we haven't really designed it correctly. Once again, 25 megapascals to 147 megapascals in this case, there's quite a big difference between those, and obviously orientating your member in the correct way is going to help you design more efficient structure, and a more safe structure as well. And we can have a look at some of the other results too. So shear Z, shear Y, shear Z. And we can see in all cases, well in this case a little bit less, because shear is generally not a governing result, but we're seeing much larger stresses on that right side. So in this case, we've gone from 0.676 to 1.65. In this case, we've gone 1.8 to about 0.447. So you can see in all directions, we're sort of getting worse off results just by orientating the section and the member in the wrong direction to where the load is being applied. And it goes for axial too. But really, the most critical is the bending, which is generally the governing result in any design, or in most designs. So that's a little bit of a tutorial on why it's important to orientate your members in the correct axes, and just a little bit about the differences between major and minor axes, also known as weak and strong axes. So I hope that helps, and feel free to leave any comments in the YouTube comments below. Otherwise, we look forward to seeing you on the platform soon. Thanks.